So hi everyone, I'm Raj. Welcome to day 12 of building a production rack system that currently supports 10,000 documents to can also scale until a system that can actually scale until 85,000 to 100,000 plus documents as well. Now this is for a fictional company called Meridian Aerospace. I'll quickly show you the fictional company. It's called Meridian Aerospace. Yeah, so essentially they have a lot of documents. They have 85,000 documents, and the documents are proportional test reports, safety analysis documents, failure investigation records, component specification, and regulatory company filings. They span from 1990s to reports. So basically we're actually working with real documents, real 10,000 documents from NASA. You can fetch that from, if you look at my past videos from NASA's NTRS, so NASA's technical server, and we pulled about 10,000 documents, and currently we are currently processing those documents. So yesterday we wrapped up processing 10,000 documents at scale. How would you do that? And we looked into a lot of stuff, and yeah, so there's a lot of heavy use of technical jargons, images, formulas, graphs, and etc. It's quite complex, and we're using a 7 billion, 8 billion parameter model to do docklink to do layer detection, and then 8 billion parameter model to do a lot of document processing, saving it to Qdrant, and most importantly generating descriptions, formatting tables, generating markdowns, formulas, and etc. Okay, so that's what we're trying to do. Cool. So I'm not able to show you the 10,000. I'm trying to connect to the SSH server. For some reason, it doesn't open up. Let me try. For some reason, it's not showing up. I'm not able to connect to it. If not, I can show you. We are actually done with 1,600 documents or something. We have about 8,000 documents left to be processed. In the middle, as I show this live stream, I'll basically show you if I get a chance, if am able to connect, because I guess it's using it's 100% CPU and there's some glitch on it. I'm not able to connect. So yeah, or something. I'm not sure what the hell it is, but yeah. Cool. So the target, this is the architecture basically. This is how the document processing itself is running. We have a worker layer that only runs on CPUs, which runs docklink. If you're not using docklink, it's a pretty decent framework to do a lot of layout detection and etc. They have Docklink has its own layout detection models and etc. I We had a lot of issues. We faced a lot of issues with docklink in terms of thread pool. We couldn't parallelly process a lot of stuff. So because of that, we have about, I guess, 8 docklink servers running, and then we have one VLM running and etc. with parallel batching and etc. I'll go through them once you should be able to see yesterday's video. I went through everything. Now today I just wanted to show you, this is what we're doing. This is how the 10,000 documents are being processed. This is the exact architecture. You could see something like this in companies like OpenAI, ScaleAI, where they have a lot of stateless workers, GPU, where there's limited amount of GPU. We only have H100s, one H100, and we're processing like 10K documents. We're doing about 120 pages a minute. We did 200 pages yesterday a minute, but there seems to be a little bit of drop. I don't know why, but I know it's okay. We probably in 3-4 days we'll complete it. Okay, so today we're actually going to solve. Now we have basically solved a lot of the issues. For example, the document processing pipeline is done. Now 10,000 documents are being processed, and all of these tables and everything is done. Today we want to look at domain specific acronyms. Okay, so let me first talk about domain. What is really what I mean what why are we really, like, why are we focused on domain specific acronyms? I wanna first of all then start up the server and then show it to you guys what we have right now, and then I can show you why we need domain specific acronyms. Essentially, it's domain terminologies. You get a set of 10,000, 20,000 terminologies, and then you usually fine tune the model. Now because I'm using Claude for this, now there's two separate things, right? The entire document processing is run by open source models, so no internet connection need, no API calls needed, and etc. Even embeddings are running locally, so that's managed. I just wanted to improvise on the agent part, so I'm using Claude for it. And yeah, this is called Qdrant Meridian. I'll start this up. I'm going to show you what we have right now, like in terms of the server. Okay, I want to show you what UI we have. I think I want to try out the agent. I have started Docker. So I just need to start up a few services, and then I need to I can just show you the UI. Just give me 2 minutes. Docker is running, so I need to run Olama. Let me quickly see if I can run the models. Alright, so I'm also running Olama as well. This is used for my embedding. So I'm having a 4 billion parameter Qwen 4B embeddings running on 4-bit quantization. That should be there. So you can see this is what I'm running. API key already there. And how should I start the API and the UI? UI, of course, simple cd web npm, the one there. We'll put it up here, and this is the UI we have right now. Okay. And yeah, the 10,000 documents are going on. Let it process. It'll definitely take a bit of time to come back. So we'll let it process. Let's start the API quickly. The API is loading. Okay. Just send hello. What is the error? I think we need to start something else as well. Olama started. You can see the request that is going through. I remember so we're taking a look at this after a couple of days, like I don't know, easily like a week back we did this, so I totally forgot what else should I start. So this is actually connecting to 8,000. This is running on 8080. It's the issue. Now we'll try hello. Okay, cool. Yeah, so let me quickly do a quick chat with the agent and show you at what stage are we there in the UI, and then of course the document processing is going on. Definitely needs the time. We can't. I'm just trying to show it to you if I can, but I'm not able to connect to the server. That's the thing, because it's either it's fully running or something. Or it's probably exhausted by now. Yeah, I think the server is like in full It's in full process, so I'm not able to connect to it. It's fine. It's fine. I'll go through them in a bit. But yeah, this is what we have right now. And I can try firing in a question, sending a quick question. Yeah, this one maybe. Yeah, I'm trying to validate the performance against a conventional methodology. A basic question which I got basically generated from Gemini. Gemini had all the chunks, so I just copied pasted the chunks and I asked it the proper question. I can remove this. This is not needed, and just send this just to show you, the sort of the tools we have and etc. We've not yet, connected this to the 10,000 documents, and there's a bunch of work to do. Definitely, the agent will fail. We want to get it right, change up things, add new functions and tools and etc. But yeah, quickly give me a list of tools that's available for the agent, and give me the use cases for it. Not use cases, just small descriptions of it. Yeah, I want to show you the amount of tool call we have. I'll be like, there's only one document in Qdrant. Just do not ask me any question. Just go ahead. Okay, there seems to be no results. Let me check. Let's start it on credit collection call. Oh, yeah. So I'll do. I want to connect to this collection, and we'll put this collection name to validation. So in the API, I want the agent to connect to this collection. It seems like some other collection is actually connected. You can see collection Meridian 10K, which does not exist because I cleared a lot of stuff. So that's why you are able to see. But anyway, you can see the number of tools called. You can see update notes. It has its own notes. It has its own tasks. It can search documents. It can get above and below certain variable like varied length of a single from a single document. And it can get a section because doclink gives us section like like 2.3 2.5. In the document parsing it gives us what section is this part from. For example, let's say you have a paragraph. Let's look at this document. You have a big paragraph, right? And here you would have sub paragraphs as well, and it will give you information on which this whether this paragraph is part of any main paragraph or subparagraph. It's not 100% accurate, but it's useful. And the description also, I guess, and depends variably on the document year. For example, if it's like a 1970s 18 document, then you might have good retrieve or good section information. If not, you won't have good ones because the parsing would quite go wrong. So view chunk image to visually verify the PDF. For example, when you process, for example, especially with documents which are very old, you can have a lot of noise. You can have a lot of, for example, let's say we are, let's look at this document, and they should have some formula, I think, and we are extracting some formula. Let's say we did miss, okay, this one, we missed something in the extraction. For this, we have custom pipelines for formula, we have custom pipelines for tables, we also have custom pipelines for figures and etc. These should be accurate. But the whole point is that, let's say in case you miss this, something happens, depending on the year, the model can actually take a screenshot of the entire thing. Like it can actually look at this specific page if it wants to, like a human being. And it can also run parallel searches as well, hit run searches where it can fire up a query, and then the query would go ahead and and the query could be different, and it basically sets the stage for the agent. When you were to ask the query, it's just in ground zero, right? It needs to know, like literally it needs to know where are you really, like where should the search happen, or what sort of document base is it. It needs to know a space, so it figures out that signal, runs a parallel search and tries to find that. And it has document get information, get visual region, again to get a visual screenshot. This is get a visual chunk image, sorry. So this was what we're doing using the 7 billion parameter model. You're basically creating text descriptions for it, so the agents can search for it, and if this were to bump in, it could use the ID and then see this image or this table visually. That's the whole goal, overall goal. And yeah, I want to show you this in action. Even I'm just trying to process this really on what's really going on, because I'm quite lost here. So here I think what we'll do is that we'll copy this, put it here. We'll put tool validation. We'll start the API. And you can see it's connected to tool validation. And now we can perform a quick search. I can just do the same thing. It's regarding some technical. We'll look into the search as before, but I'm just gonna dump in a dummy search, so you can actually perform tool calls and you can see what it could do. I'll be like, don't ask me any questions. There's only one document in Qdrant. Please look at it, because this is just to validate. Until our 10K documents come in, we're just trying to validate. Yeah, the entire thing. And you can see we're getting document information. This is metadata, so we do metadata extraction as well. That's also part of the pipeline. For example, to a lot of this document, for example, say this section, they have nomenclature. Nomenclature, I guess that's how you pronounce it. Basically they have a lot of symbols, they have a lot of metadata. What we want to do is that we want to grab this accurately. Like we want to accurately, this should be fixed for all documents. Like if the if the model needs to know any metadata that exists with the let's say the document, then the symbols are part of it. The what do you call, if I scroll up, the initial, this information is also part of authored by whom, any information on the ID, and yeah, when was this document created, because this document could have very bad metadata, right? For example, you might look into a document which was scanned on the 2000, and you'll have the metadata of 2000, but actually the document was originally from 1960s. You can have that information. So we are highly depending collecting metadata across 2 pages. So the first 3 page we use it, and we also do a lot of search, exactly like internal semantic search in sub milliseconds, I think, or maybe like a second or so, to find the symbols, nomenclature, and all of those stuff. So yeah, yeah, exactly. So if I were to go up, you can see we've got the equations quite right. You can see the sources has a very small bug. I can see it gives you 2740. There's some rerendering issue, but if you were to click on this, it gives you the exact sources of where it found the text from. Okay, these are very minor things that I can fix later. But yeah, it also has the it also can spawn multiple parallel agents as well. For example, okay, before that I want to show you, if I click on show notes, you can see the notes over here. This is the notes created by the agent, so it can create notes, it can also manage tasks as well. Something like Claude code, you can think of this as some sort of like Claude code. Okay, so we can just split this up and be like, I would encourage you to use a sub agent for this. I would encourage you to use a sub agent for this. And you could see it would do some sort of work, and then it'll actually fire off a research thread. Don't ask me any questions, just do the job. You can see the tasks, you can manage tasks, it has a list of tasks, you can see. Yeah, I don't think it used a sub agent. We'll clarify it one more time. Please use a sub agent. Just go for it. Don't ask me any questions. And you can see parallel search. Now, of course, it didn't spawn a subagent. I mean, it's just naturally we shouldn't tell it to spawn it. Only if it needs to, it'll do it. Because very straightforward query, and you can also see it did a lot of parallel search as well for very different sort of information. It was able to do it. So like stuff like that, like very generalized sort of approach where just trying to just this work is very domain related, very domain oriented, and I myself have to read this, just read through the documents, read through read through not documents, actually read through the use cases, read through the personalities. In fact, we actually did a lot of personality assessment. If I were to show you here, maybe not in this, we were actually looking at two people who might use this platform called Sandra and who's a very senior research engineer and a very junior engineer. How would they really go about in a day? What is their thinking pattern? What's their current tools? What are their traditional tools? How would they perform searches? Is what sort of search looks like, and what makes the answer quite well? What adjacent information would they need? Like, could the sources just be like sources, or would we also need to show something visually and all of those stuff? So there's still a lot of the work, a lot of work is I mean is yet pending on this. But in terms of UI, you can see the sources, you can see the sources in line as well. But yeah, this is the stage we are in. I want to quickly show you the parallel search, and then I want to have, like, please spawn a dedicated investigation thread or subagent. Okay, and you could see it can spawn a subagent. Yeah, and it's asking me to. Don't ask me any question. Okay, and you can see a research thread, and it's opened up a research thread. It has a task, it has context, whatever context is actually gathered for it, and then it's actually performing on. So basically, it's the parent agent. So for example, you see all of this, right? This is that agent, but it doesn't have the capability of or to spawn a research thread. So it won't be. We don't end up in a recursive. Agent spawns a new agent, and the other one spawns a new one. Like, we don't want that to happen. So there's only one level of deepness, like the deepest the agent could go, and we don't let the research thread to launch another research thread. That's it. But it has access to all the tools, all the documents. It's just basically it's just a clone of it, really. Okay, and it's writing the final reply to the main agent. You can see the research thread launched the research thread, and you're getting a final response, which is quite accurate. All right, so this is good enough. I think this is what I wanted to show you. And yeah, quickly, if I want to, if I quickly, I wanted to quickly just dig through why do we really need to solve domain, like domain specific terminologies. Like, why even bother to do it, right? So I want to first of all go through that understanding, and then we want to jump in directly to see how could we how could we really what is the most useful way of using domain terminologies in this context, not just letting the agent search for anything it wants to, because it doesn't make sense to do it in the first place. So that's what I wanted to look at. So let's go through the understanding. What I'm going to do is that very simple. This is the project. I'm just gonna copy and paste. to Claude, I'll be like, this is this this is what I am working on. I'm planning to use NASA for the, it's called Thesaurus. Yeah, it's here. GitHub is actually also available. You can actually load the dictionaries from GitHub itself. It has about 18,000, maybe even more, like 18,000 more. It has taxonomy. It has not just for rocket, like the domain that we're working right now is aerospace document, but it also consists documents from bio, astrophysics, I guess earth sciences, life sciences, and etc. So a ton of different domains. Some of the words that I can't just pronounce, but yeah, very interesting. Sort of for a field to be in. Field to be in. So I'm planning to use NASA's dictionary slash thesaurus. And I'll be like, you know, I just want to get into I just want to really understand, the real impact of, okay, for example, I'm basically building a RAG agent, and because I'm using, I'm using a closed source model, I can't fine tune the model. So I'm planning to build a RAG system on top of that. But before, I just wanted to get it very right. So I wanted to understand why even domain acronyms or terminologies would really be useful at this scenario. Why would the agent need to do, and why would the system, how would it really help? Like, I wanted to really understand, and also any other information, because I think there's a lot of unknowns for me. So make sure to give me any information that I should be aware of when working on this in the agent, because I want to really understand, fit it to a very proper use case, and fit it to sort of design it in a way that solves a problem in a very neat and a valuable way, instead of just writing or dumping some code. So I wanted to understand all the background context. Now, how would the documents be, what are the general documents like, and what's the nature of them, and why would domain acronyms be useful, and is there any tips and tricks how people would, I'm sure it wouldn't be just search up some domain acronyms and just go ahead and dump it. It'll probably be something different, connected to the query that we are working with, or the system we are working with, and etc. So just I want to understand the whole background context and the work that, or the context that that should be present, for me to understand, and then I could probably make some decisions. And feel free to share your thoughts as well. Cool. So essentially, what I'm trying to, just emphasize on is that, I'll have a lot of information that I don't know, and I do this sort of random trick always. I usually do a lot of random tricks where, just open up the space for a lot of random information, because then you could actually have a good possibility to make some decent. Yeah, you'll come across a lot of new information, like because particularly at this field, I have no clue about a certain terminologies. Why wouldn't you use them? And what I can do is that I can generally copy this GitHub, or maybe just use the API to download the 10,000 or 4,000 acronyms or whatever, put it into RAG, and I'll be like, before you search, just go ahead and search it, find the meaning, go ahead. But that's not the real point. That is something different about using like terminologies in this space. It's not just about the word. It's probably some more semantic meaning, or there's some background context to it. So visually, I'm trying to present it on on my head, is that document processing is done. That's the first part that is actually done. And then you have which is, let's say your company is coming in, right? They give you 10,000 documents, you have to process them. They have tables, formulas, and whatever, metadata, and etc. Document processing is done. You have that, and right now the document processing is actually not done. It's on process. It's a I've already done about 1,700 documents, and there's about 8,000 documents that's left. So it'll take 2 to 3 days, and we've got enough time to work on something else. So in terms of a solution, that's done, and the requirement was quite simple as well, right? They have the 85,000 documents, and that's the hard part. But in terms of documents, most of the documents are coming from 1950s to 2000. So you need to have a way to embed them properly, which we have solved. Then that's good. There's mathematical equation. Yes, done. Actually, I'll use an icon here. So then because I totally forget. Like, I'm sorry, I have this. Yeah, I just easily forget things, so I'll just use an icon. We've done this. Tables, they are telling us, we have a lot of tables. Okay, yeah, okay, that's done. Cross different documents. This is an agent sort of thing. We'll work on it, but decent is done. Heavy use of technical diagrams for processions. We have done the document processing, and we've also used OCR and also no OCR models to get in. Yeah, so 40% scan PDFs with degraded quality, photocopied, faxed, or rescanned. So we have OCR for some of the documents as well. And yeah, and natural language, yeah, we have the basic stuff done. System must understand this, and legacy system without returning garbage results. Engineers should be able to ask questions like what chamber failures have we seen in Bipropellant system operating in 2000 psi and get relevant historical cases. Yes, and the system value is 7000. So most of the, like, in terms of document level is actually done. And now we're trying to understand why domain specific acronyms. I have no clue about this, so I've asked Claude for it, and Claude has given a reply, so let's just go through them. So this is exactly the right mindset, understanding problem domain deeply before architecturing the solution. Let me walk through the core problem. I mean, of course, you can of course go through them with me. Why domain? Yeah, so just to summarize, I've got a decent understanding. Makes a lot of sense. We're using an open source embedding model, which means it's worse than OpenAI or Cohere or any other closed source embedding models. So I mean, in generally, it'll actually have very the small amount of aerospace knowledge, right? So by propellant should actually match. So this is the expectations. At least what I get is that if the user were to ask a question like this, the current system, because we're using Claude, it can do some decent work, but not 100%. It'll probably go ahead and just search for bipropellant. If it doesn't find it, it'll be like, no, I'm not able to find it. I was not able to find it. But in fact, biopropellant would actually mean very much different mmh or nto. Like, it's totally different. Like for me, as a general odd person, like, just biopropellant is very different from mmh and nto. It's totally different, right? I mean, for me it's very different. And you can see it's nitrogen tetroxide or LOX RP1 liquid oxygen rocket propellant. So you can see the level of acronym is there. It's just biopropellant. The agent, if you were to go ahead and search, or what I would do is that I just fire off this in the agent and you can see it for yourself what it's actually going to be searching. You can monitor the search tool, right? It'll add its notes, and maybe Claude could be a bit smart enough, and you can see over here, no mention of, like, zero mention of technical jargons. And I'm gonna scroll up this idiot. And yeah, I'm just gonna quickly, yeah, you see this, right? Thrust chamber failures, high pressure combustion chamber packing, bipropellant engine fatigue, thermal issues, PSI. Like, there is no one query that actually searches for, where is it? No one query that actually searches for LOX or MMH or NTO. This is where failure actually happens. This is where domain terminologies would actually, and this is such a clean domain to work on, such a needed domain to work on. Of course, you have things on legal side, you have things on finance, but not as worse as this. Like, where, and I think this is one case, and pharmaceutical companies is also one. I think they work with a lot of medical jargon, but generally, whatever space or a domain that is filled with a lot of jargons, and if you if they were to use a generalized RAG system, it'll most probably say fail. It'll just, even the document processing is really great, it'll just fail because they have no clue, or the search terminologies have no clue about the domain expansions. So you can see one example over here, and our system essentially failed today. You can see it just failed. It was not able to find it. And the embeddings, I mean, the thing is like this, because if there's 5 documents, 10 documents, okay, but if you have, for example, with about 1500 documents, in our actual code we have about 273,000 chunks. It's not joke, guys. 273,000 chunks. So in that 273,000 sorry, 200 around 280k chunks, right? We'll just call it 80k, 280k chunks. How do you go and search for the, or pull up the right document? Like if you were to, there is no miss. You can't do any miss. You won't be able to, search for trust chamber. And if you don't find MMH or whatever, most of the time you will find documents which sort of correlates with the query, or the query, and the agent could assume it to be right, but it's actually not right. And you will have really good retrieval when you use when you actually use not document domain terminologies. And if the model actually understands it's better, the queries could become much more better, the search would become much more better, the overall system would be much better as well. So anyway, that's my understanding till now, but let's just move on. It's just the same thing, right? 2000 psi would match 13.9 mpa. Like I have no clue, right? Like literally for me to, like fire off a question and just give it to Gemini or something like that, or if I were to validate it in any way, like I'll probably assume this to be right. But you can see 2000 psi would actually mean 13.7 mpa. And if you were to search 13.7 mpa with 2000 psi, you would probably end up with very good results. That's the generality of how embeddings work. So one case, so that's something they're good to look at. So I'm going to go through, read them, and sort of explain you. The thing is not to explain you. Of course, you guys are smart. You can really understand it once you see it. I'm just explaining it to myself. Assume it like that. The retrieval fails not because relevant document doesn't exist, but because the semantic distance between the query and document is too large. Exactly. The distance is too large. And if you were to look at the embedding space, it has, I guess, by the time we finish 10,000 documents, we'll easily have 800,000 chunks. It's not 1,000 chunks. It's not 10,000 chunks. It's not 100,000 chunks. It's 800. It's nearly a million chunks. Like if you were to see, how do you go ahead and find, how do you reduce the distance? Or you can look it in a very small way. Let's say you have like a circle, right? The overall goal, what we're trying to do is that, how can I show it to you? How can I show it to you? I want to show it to you visually. Okay, for example, yeah, this is a good example. Just assume this is what we're dealing with. This is Google Maps, of course. Just I'm just using this for an example. Now, this assume this entire image you see is the embedding space, 800,000 embedding space. But what you want to do is that when you go to search a proper query, you don't want to, like, you don't want to end up in White Bay Cruise Terminal, or you don't want to end up in Potspots Point, or you want to be accurate enough to end up in a closer in a what do you call, I can't get this bloody word also, uh in a in a in an, I can't call it accurate, but you can call it in a space that would open up more possibilities. For example, see over here, right? If I were to search what is it, Museum of Sydney or something, whatever, doesn't matter. If I were to end up in this point, this is the radius, and what we're trying to do is that in 800,000 chunks, we are trying to minimize that to just 100,000 chunks, and then inside the 100,000 chunks, we would do the re-ranking. I mean, we're not going to do re-rank for 100,000 chunks. That's not what I'm saying. What I'm trying to say is that in very different way, we would try to reduce the number of locations, or the number of space between each coherent chunks, maybe you can put it in that way. And then what we do is that we slowly expand the radius as, if we don't find the information. That's the smartest possible way, because you have 800,000 chunks, you can't end up searching all the places. But what you can do is that if you do have the domain terminologies right, and if you have the clear sense of the, if you have a clear sense of the question, and if you have a proper query, and if you were to find or filter it by, the year of documents or whatever, in a very small space, not 800,000, just 50,000, and you put on a radius like this, and then you start reasoning over that. This is a very bad example in terms of visual. In terms of visually, it looks good. Just assume the entire image is 800,000, the ball is actually 100,000, and we're trying to expand it as we come across new information, or if we don't find information in this existing zone. That's what we're trying to do. And So essentially what we're trying to do overall is to just reduce the semantic searching space, embedding space, where the agent can work on. So then you can has the it can have the right signal, because if you were to just like normally search for 2000 psi, you'll find, like, I don't know, in 800,000 chunks you'll easily find 150,000 chunks which might mention this. That's not the whole point. It's the entire query, it's the entire context, it's the entire adjacent meaning and whatever coherent sort of work you're actually dealing with. It For folks who think maybe this could be a very, I would want to structure this in a way where we only focus on domain terminologies in this specific episode, because I think, if you were to look at in my last videos, we had a lot of issues, bugs, and etc. This would be a clean one because it's very straightforward. The overall goal is to build up that meaning and understanding for you to build the project, not just use some sort of verbs and just put to the agent. That's not the whole point. So I just want to go, and I did the same thing when I was designing the document processing. I did the same thing when was designing the entire agent. We did a lot of simulations. We were in the shoes of the actual users, and we tried to understand what is a use case would like what could be valuable, what is their mentality would be, and etc. That sort of gives you a lot of good personality, which you can use mostly to build up the domain intuition of the model, and yeah, I don't want to repeat things again and again, but anyway, cool. There's a concrete example. I'm just going to read through that. This is retrieval failure that caused Meridian to miss the critical failure mode. Okay, this is an example. The nature of aerospace documents, understanding the document structure. So yeah, we have a decent sense of, if you follow the other ones or so on, have got a chance to see or read through the post or whatever, you could necessarily understand it in a quick way, how a document, or maybe in the initial video I showed you how a specific document would actually work, how look like. So they have a lot of jargons, this and that, but we'll build up the understanding one more time, not an issue at all. So they have test reports, likely 30% of the corpus. They have a lot of tests. Objective is to qualification, hot fire, and whatever. This is how you have tables here, and then you have results and whatnot. The anomaly section might be 50 words in a 15-page document, but that's the part matters for the failure mode searches. Your chunking strategy needs to preserve this context. The anomaly section might be 50 words in a 15-page document. Okay, it might only be 50 words in a 15-page document, but that's the part that matters for failure mode searches. Your chunking strategy needs to preserve this context. Yeah, essentially what they're trying to say is that in a given 15-page document, the answer to your query, or you could call it, in every query you will have a couple of things that would actually influence the path or influence the worthiness of an answer. So for example, if you were to ask about PSI, it's about PSI, and it's about very adjacent text. For stuff like this, a 50-word paragraphs could actually, most of the time, would lead to a great path, or would give very good insights for the agent to move on or maybe find the answer. But if you miss to find that in a 15-page document space, which also has another 9,015-page document, then you'll be in very bad trouble. So yeah, that's one point. I've not yet planned how I'm gonna solve it, but yeah, we'll just figure it through. We'll just yeah, I hope we can figure it out. So failure investigation reports, these are goldmine for institution knowledge. Event chamber, failure investigation reports. Oh yeah, we've seen this as well. Root cause and the cross references where institution knowledge lives. A good retrieval system doesn't find the document, understands these. Okay, here I could. So this is also giving us insights on how our retrieval should structure, how our agent should actually structure, and etc. Because you can see usually like in a typical environment you have 30% of corpus being test reports, and 30, and I don't know, percentage is not shown here, but failure investigation reports might be a lot, and that might actually reference many other documents. So the agents, like when the agent were to get exposed to a document, it's not just looking at this particular text. It's actually it's I think if I get it right, if it were to find, or I don't know if it's helpful, but if it were to find good information, you should also search the references, like, and check if there's any references document um to be able to refer them, because right now I think you might come across this paragraph, and that's very highly valid, and that makes a lot of sense. But if this paragraph or the chunk, or this the things like this, you search up something, you get this information, this answer is right, and you have very different similar answers for your query. Now your references will actually not be part of the chunks. You have to look into a document and you have to search up the references most of the time. So I think if the agent were to be a bit proactive enough to usually refer to references, if that's helpful, that could, in a given document, basically we have access to this chunk, we can use the chunk id and then get the references of this document, do a semantic search and try to find if there's any, if if there were any cross references. So that's a good point that I have. Maybe we should come back to this and emphasize. But yeah, cross reference documents, component specification dense with all of this stuff, qualification requirements, regulatory documents heavy on traceability, hazard analysis, failure mode, verification matrices, how NASA Thesaurus actually helps, and its limits. Okay, so we are gonna this would, I was not aware it had limits or whatever, but then I guess it's for the use case, but we'll just go through it. Preferred term, combustion chamber, narrower terms, rocket, this thing, related terms, this thing used for synonym. I don't, it's just, I don't think it's hallucinating, but it's just making up things. I don't think this is how it looks like. It's quite different. I think I can still check it out. I want to check it out, but yeah. And yeah, essentially it's a bunch of acronyms, guys. Like for example, combustion chamber will lead to this, related themes could be this could be this, and etc. And you have narrower terms which could be this. Okay, preferred term is liquid rocket propellants, and then you have narrower terms which could end up here. Now the thing is like this: the user could actually search for mono. Oh, no, I'm not going to spell that. I'll skip that. So hydrogen propellants, right? The user could specify hydrogen propellants, but it should the rag should also, or because in this case we are retrieving stuff at the end of the day, you should pull up this and pass it. So the rag could search for this is and this, because there's no one preferred term the user could search. So the user could even just directly search for MMH, and some of the documents might you know mention NTO, or if the user is very if he is a pro user of the system, if he understands the system, and if he really wants to put in a lot of jargon, the user can directly put in jargon. But still, we still wanna do the retrieval and sort of be what do you call, be we still want to do the make the retrieval as part of the general process, like the entire process. So the queries could actually be valid. For example, if the user were to put MMH and NRO or something like that, MMH is valid, NRO I don't know. I don't want the agent to go ahead and search for NRO, but if it could do a quick expansion on the domain terminologies, get that context and go below, I guess there's a good chance of success rate over there. All right, so how would you actually use this? Just a minute, guys, just like 10-15 minutes and we'll jump in. How you would actually use this option one, query expansion by query. Yeah, so this is what we are going to do. Option one, query expansion. Query expansion meaning not the user's query, but the search queries. Option two, document enrichment. We don't want to touch the document. We don't want to take that risk, because why take why would we update the original document when we can just work with the info that we have? Because the documents we're dealing with are very much, they're quite old, like 19, one of the oldest document that I dealt with was actually 1951. So if you were to go ahead and search for MMH, you might find MMH, but that's just document processing work. You just don't need it. Do both? No. So I'll just leave this. I'm not gonna bother to read it. Oh, actually, limits of thesaurus approval. The NASA Thesaurus helps with vocabulary. It doesn't help with company internal terminology. Meridian probably has internal acronyms, programs, names, jargons, not in us. Thesaurus, it's okay. What was might not be thermoacoustic instability. Okay. Then this is something that we can't do. We want them to add, like, how would they I'm not sure. So this is another question. I understand about the limitations of NASA Thesaurus, and I understand company internal terminology, but I want to know the reality. Do they have a specific documents that details their, like, their internal terminology, or is it just based on documents, and is it like a know-how in the company? Because if not, in our ag system, there is no magic to really, unless you do a lot of pattern matching or something like that, or design a model for it. There's no way we can capture company's internal terminology in the right way. Keep the answer for this very concise and short. Okay, there's a lot to read. We'll quickly go through. Hmm. Yeah, critical test data lives in tables, so we are able to extract all of this accurately. So that's part of our documentation. It's done. Knife chunking destroyed this. If your chunk boundary falls in the middle of the table and you use the ability to answer which test failed above 2 MPa, yeah, 2 MPa, that is an issue, but we've solved it. Unit consistency over 25, you will see fresher. Yeah, so this is a good point. Unit inconsistency. I'm gonna actually open this up and just add this up. I think it's important we note this down. It should be part of the RAG system as well. So the heading here called uh, uh, actually, unit consistency was one, and we also came across something else. Cross-reference documents. Okay, I'll just put this here. So I mean, of course, my notes are very bad, but when I read this, or when I just come through, like when I read this particular text, I can just remember the entire context of what we read out, and I can just try to go and read the document. And document cross references, failure report, root cause consistent with. Yeah, engineers don't want text about thrust curves. They want the actual thrust curve diagram. This is generally hard. Options: use a vision model. Yeah, the thing is like this. We've already generated model captions and descriptions, and the model can actually, when it comes to description, the model can actually visualize it as well, not just the description. Descriptions are only used to just locate the right this thing and then pull in the image. And I want, at the end of the day, in the chat, show the images as well, so the user can click on it and actually see it. This is okay. The senior heads problem. The problem statement mentioned institution knowledge locked in their retiring engineers. Your RAG system can retrieve documents but can't retrieve on test. Well, the test series had bad propellant batch. We don't trust any of those results. The 1997-2002 used a different coordinate system. We stopped using the failure categorization after the 2010 audit. Consider separate institutional node corpus that senior engineers can add to, linking to the documents. Wow, yeah, this is very good. I'll note this down. We can have it as a feature actually. But I want to know, how well it can be a feature, because I'm pretty sure the engineers are not like wandering around to, coming to the system and type in institutional knowledge 1, 2, 3, 4 and stuff like that. So yeah, that'll be hard to find. The chunking strategy, this deserves deep thought. Don't care about, I don't think we need to care. We solved this stuff. I don't want to spend time in it. With paragraph structures, section vary. Yeah, yeah. Yeah, we've solved this. I'm not gonna confuse this. My recommendation, I don't care. How I approach this, document understanding, get retrieval code, get sample. It's actually given me like an entire pipeline. Like, we've already done it. Integration user query, failures in biopropellant systems above 2000 psi. System one, term extraction. It could extract the terms, yeah, and then it'll actually, yeah, essentially do like a parallel search, I would say, for all five. And I want this to, my goal is to get it in milliseconds. So let's see how easy or hard this can be. Like, because once, I mean, I'm not talking about this, like the query, this is dependent on model. Once we have this, I want this and to this come in milliseconds. I think we can try to do something in that, or maybe less than a second. That's what I want to do. Because so then it feels instant. It feels instant to the user. The user pumps up a question, and then the agent starts thinking, already starts scoring tools, and there is no question of whether it like like for a normal user, he would never notice that the model did actually looked into domain specific, no, bloody hell, what the thesaurus, you will call it thesaurus, the thesaurus or the domain words, domain specific domain terminologies, we call it DTs, and pulled in all of the all of the adjacent text or meaning or whatever, and then it actually did the query. So that sort of impression, that's my goal, is to just, the user would never know that we did internal search queries and populated it to the agent or something like that. It'll be so the goal, so you can only achieve that if fire it off in less than 100 seconds. In fact, it should be actually the a proper way should be actually under 500 milliseconds. That's the touch point where the user wouldn't feel anything. Like less than a second is where it's usually natural, and a second you could see a small lag. It's waiting for a second. You can see that. um but yeah, we don't want to spend a lot of time on those stuff. Very easy, just keep a small goal around second or less than 1 second, it's enough. Thesaurus expansion, you'll give, it's very simple, guys. We just do a simple search and get a bit of text, pass it to the agent, and then the agent would start searching. Simple. Blah, 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 blah. You're right to push on this. Okay, I asked about the internal terminologies. Most companies don't have a formal internal terminology document. It's tribal knowledge. It's a tribal knowledge in people's heads, scattered in email threads, maybe in wiki. Nobody maintains. What you can do, mine it from the corpus itself. Frequently analyze acronyms and terms that appear often into documents but aren't in NASA Thesaurus. That's your internal terminology. One workshop with senior engineers, 2 hours, show them the extracted terms, asking what's missing, what do we actually mean, what's your ROI, accepting imperfection. Your system can't capture everything, the system gets better over time. Yeah, cool. I guess we're in decent point. Let's jump into code and we'll actually get started, I would say. Okay, we'll skip this. And okay, I think it's a very small conversation. Production architecture, and even though, okay, I'll create a new Claude. Let me sure you understand. Should you understand the agent? I itself forgot what the agent name was. Yeah, I guess this is the agent. Make sure to understand this agent and relevant context around it. She had development plan here. And no, we didn't have anything on terminologies and any relevant context. Next, we want to work on supporting the termin terminologies. I want to give you some understanding about the project, because yeah, I don't think I've saved anything. Project info, yeah, I'll just keep this. And black question and relevant concept we want. We are trying to build and be like development plan, project info. The hell? Yeah, this one. We are we should use also Thesaurus for this. This on this current code. Mainly agent. Come back to me. Let's be working. Yeah, I don't think we'll extract for yeah, failures might have malfunctions, erosion, whatever. Okay, okay. Then find so this is just an example. Yes. Mm. Oh, sorry. Correct. Is anyone down? Mhm. Actually, we know that there is a GitHub. We can pull the GitHub, but I want to know in case I missed any information and stuff like that. In case I did miss some information, I don't wanna, or just to randomly let it find me any info. I might discover something better. Maybe like the GitHub I did before. There's like an API for it. I can just pull it, or maybe downloadable file or GitHub or whatever. I wanna connect. Oops. Yeah. Thank God we connected now. Okay, I'm gonna go to Meridian. Go to search for C, and I want to quickly show you uh, the GPU process we have right now. And whatever to connect. I guess it was Watch N and NVIDIA SV. And you can see we nearly utilizing 95% of the GPUs, even more. We have docking servers. All of these are 8 docking servers. We have a co VLM which is running by VLLM. We do a lot of the batching stuff. So I guess that we are ranging in terms of token speed. I don't know, maybe 3 figures or something, 300 tokens per second or something. Per second, yeah, actually, no, 120. I don't know, but it's a 7 billion model, right? It has a very good token rate. And this is Olama for embeddings. To quit this, I want to quickly show the progress we've made yet for so far. Let's go to this and refresh. Actually, go to 603. Okay, whatever. And yes, you can see we have 15.5% done. It's running for about 15 hours right now from yesterday. Completed 1610 docs, total 10,000 documents. We have a failure rate of 6.7%. My assumption was that, even if it fails, we can do another this thing and, process the failed once. Plus, like 10 to 20% of failure rate could be a possibility, because we're working with not like public docs here. Some of them could be corrupted, some of them might not have, it might miss some information, so stuff like that. And you can see we're doing about 106 pages a minute. We started with 200 pages a minute, and now it's doing about 106. I don't know why it's going, why it's this slow. Maybe because of, I don't know, whatever the reason it is. Yeah, but either ways, yeah, I just wanted to quickly show. I was not able to connect because maybe I just connected to a multiple amount of times and it did not process it properly. I don't know what the reason is, but yeah, I wanted to quickly show this. So this is going on. I think we already have about 9,000. We have 100,000 pages already in Qdrant. So, and we only there by 15%, not even 20. So we'll end up in about 100,000 chunks. Sorry, 1 million chunks, something like that, around 1 million chunks in day probably by this Thursday or Friday, but by Thursday we've wrapped up the project. I can't. I'm probably doing this about 12, like 2 weeks right now. So I'm gonna wrap this up quickly. So yeah, I wanted to quickly show it. Let this stuff go on. We will definitely complete the domain terminologies, and by then tomorrow we'll have, I don't know, easily 300,000 chunks which we can start working. And afterwards I'll give you my thesis on what I think, just the thinking patterns towards how to build a system at scale, and why it's actually simple when you solve all the core problems. And then um, mm, um, yeah, you solve all the core problems, and once you have that system ready for a few hundreds, it's actually like, you have this theory of finding the needles in a haystack sort of test case that happens to all of the models, right? You have a lot of information, you want to find just that right information. That's what we want to do. Doesn't matter there's 100,000, doesn't matter there's 200,000, doesn't matter even if it's 1 million documents. You just have to find that 40 or 50 documents among that documents. But that's the complex part. How do you do it? You can't, it's not. See, and the solution is not just using an embedding model, search up and find. That's not the solution. It's something else. It's with filtering, it's with, depending on the domain and stuff. So we look into everything. I wanted to quickly show it to you anyway. So cool. Yeah, let this run. And yeah, so I don't want to go all of this, just to let Claude build up some understanding about the current system we have. That's it. And I think this GitHub, the repository contains a collection of NASA's Thesaurus technology related document, as well as Python script to load concepts from SKOS file. I can just directly use it from NASA. I can just directly use it because this is not maintained. I'm not sure, if NASA, and this was 8 years ago. It's quite an old one. I know the API would, I know a lot of the information would have changed by now. So I don't wanna stick to this, but yeah. And same thing, we also use an API for this as well. This is a free API. You might not, you don't even need any authentication token for it. You can directly query it, but you have a limit of 500 PDFs per minute. Wait, no, actually per 5 minutes or something like that, I think. Per 5 minutes or minute, I don't know. Like 500 pages, you can only download 500 for every 5 minutes or something. Then we had a workaround. And by the time ran it over in the evenings, went to the gym, came back and then did some of the work. And morning I woke up and started the server, it was actually done. So probably like 10 hours maximum to do like 10,000 docs. Yeah, and you can of course run it in very different VMs with different connections, and you can even do 1,000, 2,000 per second if you want to run it. But the thing is, you might have a lot of duplication. Yeah. Anyway, this is running. So yeah, I don't want to use the GitHub because it's quite old. But yeah, let's see. Now I have a complete information. Let me compile a detailed summary for you. Analysis, English understanding. Yeah, build, yeah. Injection point for DT is mainly domain terminology. The domain is build system prompt. We add domain terminologies. Now, so does it. The overview 18,400 subject terms, 4,300 definitions, 4,500 using cross references, synonyms, covers aerospace, engineering, propulsion, physics, space sciences. Download form is available. 66 MB, full terms and relationship definitely, full anthology, standard. This thing, I think. So SQL structure, what we'll work on, this is the structure they have. Key SKOS. What the hell is SKOS? SKOS? What does SKOS mean? Simple knowledge organization system. Okay. Oh, I was not aware of this at all. It's a W3C standard 2009 for representing structured vocabularies like thesaurus, taxonomies, and classification schemes in a machine readable format. Key points bullet built on RDF resource description framework, part of semantic web standards, designed specifically for control vocabs, not general ontologies, simpler than a full OWL ontology, just concept and their relations. The core ideas representing the concepts and how they relate. Okay, understood. Yeah, it's a standard. Full terms. Okay, download pre-fill primary term, and then you have synonyms. Now, thing is like this: people might search for synonyms as well. And then again, if you have like a decent rag semantic search, you can still pull this. Broad the term, narrower, related, and also definition. Proposed architecture for DT support. Storage, SQL Qdrant, parse SQL index terms with embeddings for fuzzy matching. Store relationships, all tabs. What? Actually, I want to add it as a, for example, let's say you have Bipropellant, right? And you have, I just want it to be basic text. I think query, NLP search, or Claude extracts terms pre-call and or embedding based on rejection. Lookup, term related trust chamber, lookup and Thesaurus, get all tables, related narrow terms, get unit conversions. Injection, augment agent context. Option A, inject into system prompt, prepend the user message. Yeah, I'm also curious to know. Okay, forgot. Hmm. Okay, I wanted to know something. Oh yeah. So do we need, so I think there's a couple of things I need to download, but I'm just curious to know for this system specifically, would we need all the 18,000 vocabs? Would that be useful? I just want, to get that even very small amount of accuracy if needed, possible, if this could help out. But just curious to know, do we need all of those 18,000, or could we just, get the same with a few thousands, or just a few, just a little. Mm, yeah, just want to know that. No, 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 we can't do it. We have about 10,000 documents. We can't run matching right now. It doesn't make sense. And this is such a stupid idea. Just, yeah, if we can get away with 4,000 terms, then fine. But how would we, what do you want me to download? And how would we get that 4,000 terms and all the acronyms? Open sensitive. That's such a huge one. Definitely, I think. And yeah. Okay, download this. So we are downloading it. We have a huge CSV. So what is the downside if we use 8,000, 18,000? Because it's the same script and we don't want to filter anything. If we were to, I mean, they already have it in a proper format. Right? If you were to grab all the 18,000, would it still help our system? I want to understand in case in filtering, if we miss, like, because we have no clue what we're dealing with, but I know it's domain terminologies and it has synonyms and etc. I will only be able to validate it once we have the embedding search up and running, where I can search and it pulls up the relevant information, because there's 160 records and I'm not a research scientist, and nothing would make sense for me. So you're right. There's basically no Dataset turning. Well, if it doesn't matter. Storage 18K relations may find them in negation. With okay, 18K lookup is only O1 with a hash map of trivially fast with embeddings. No difference. Noise, false positive. This way, my initial concern, but it was unfounded because we only look up for terms appear in the user's query. Yeah, exactly. The user's trust time failure, we look up for trust time failures. The 14,000 Schema biology terms just sit there unused. They never inject noise because they never queried. Benefits of querying all 10K material sciences, you get access to all the stuff. Yeah, skip the filtering. Yeah. Yes, and let's write the script. Before you write it, you're going to store this as embeddings, right? And that's what we want. We want to be able to search it through embedding. How are you going to store it as an embedding? Would it be text based? What is the structure for it? Like, how does an each chunk look like in an embedding? Just curious to understand. Yeah. Also known as TC, or just pulling in the all labels. This is good, but should we also include broader, narrower related, or is it not necessary? Okay, it's still saved as metadata in this, and yeah, yeah, makes sense. Let's write the script, because all of this would actually be part of the agent. Like, even though the matching wouldn't be, but this will be part of the answer. So it makes sense. Yeah, it will actually make sense. I want this. Done. Oh, that is quite. Oh my god. Okay, so we have 18,330. Oh shit. 18,336 concepts. Concept is synonym 3,334. 4,503 synonyms. 17,002 broader terms. 17,001 narrower terms, and 117,340 related terms. Okay, this is a sample here. Convention ID, you have embedded text will be this would be the main one, and you have the other alternative text related. So okay, I think mhm. Oh, okay. Actually, close this. It's a big file, so that's why it's crashing my VS Code. This is fine. These are fine. It's crashing my VS Code. Okay, we'll be like, no, no, let's skip this out. But you can see the process was done and completed. I'll copy this and save this. Or maybe I'll just run it. Okay, and this is done. Done. Now, simple guys, we just have to do the retrieval part. And yeah, just check it for ourselves. And the search query should change up. When you were to write a search query, it actually you need to influence. You want these queries to be influenced by the broader terms and synonyms and etc. Expand this, and you can see we're searching for broader. You get pressure, you get combustion chamber, specific impulse. I don't know how to spell it. Injectors, high energy oxidizers, and etc. Okay, same thing for the other searches. Okay. We have good data. See examples. Embed and store, load into Qdrant, separate collection. Yeah, separate collection. Yeah, let's build a lookup service. Once we test the lookup is working fine, then we integrate to the agent. And also note, just curious before we run this, from query to return, how much time would it take? What do you think it'll take to get the matches? Let's say there was like we can I want, like, for example, for a query you might have 4 searches or matches you want to run, right? And we could do 4 searches parallelly, but I want to know how much would be the time to get the response. I want it to be less than a second, because that's when the user, it feels like I don't want to add a lot of time to the agent, because if you were to take a lot of time for this, uh actually, you know what, I'm not gonna do that. I'm gonna first of all measure how much time it takes, and then we'll find, first of all, yeah, first of all we'll work this and then we'll make it fast. Let's not think about that right now. So okay, you can see the request having made. Oops. How many embeddings are you storing in a single batch? Uh, I have a 24 GB MacBook Pro M4 Pro. How much? I have about 24 GBs of RAM. Maybe if you were to use that, even if you want to use 10 gigs, how much? What's the max you can push it to? I'll just leave it as is. It's okay. It's already 20 done. So also just leave it as it is actually. You can see my fans are kicking in. So I'll just leave it as it is. Before you make this change, could it handle? Right now, this is this case. Yeah, let it run with this. Should be done in 10-20 minutes. And you can see we have now the Thesaurus. And we're storing 18,000 odd something. Just a minute. My fans actually kicked. It's actually kicking. Oh my god. Yeah. Actually, see the power of NVIDIA GPUs. I'm actually, Mac is actually struggling for this, but we actually did how much? Yeah. NVIDIA, we did 128 parallelly for 8. So we did 120. Just time it and see. Oh, it's such a huge number. And the embeddings are being stored, so we'll give it a bit of time. 7,600. Nalika. The good thing is that like even for small stuff like this, the Mac, even I used even running embedding models. If I had like an 8 GB version, I can't really run it. And see, I'm able to like after getting this new, I just got actually a new M4 Pro 24 gig one, and I've saved so much money instead of spending GPUs. Or usually I spend a lot of money, easily $100 a month in RunPod, easily $100 a month in RunPod. Um, to run some embedding model, because I only have 8 gigs right now. I can just run embedding models. I can run very small models. Yeah, it's quite helpful. And of course, like I actually plan to process the entire 10K on my PC, just run it for a couple of days 24/7. But then because you can use max layout, not layout detection, max OCR. uh, but it's okay. Then I actually I basically wanted, so that won't be much scalable. In a real world scenario, you won't run it on a Mac, you'll run it on an NVIDIA GPU. But you guys have to know how do you even run it on a GPU? What are the constraints? What are the what are the drivers and all of those stuff. So we covered all of them in the last video. The thing is like the audio, it's not like a video, it's a full stream, and it's like very long, and it's like not a tutorial where I would go ahead and just show you things. It's just I'm just bluntly working on things, but you should still get some sense of what's going on. Like you can just see it, or when I add chapters, you can see skip to the relevant parts and just see how the problems or whatever is necessary is actually going on. The thing is like this, I on the first stream it was totally with bugs. I had a lot of bugs, and then the second stream again bugs. Third stream we rewrote the entire production architecture to support. We basically did something like a very mini ML service optimization might work out. We moved it to a lot of CPU workers, CPU services, and etc., and then handled threads and etc. And then later it actually worked out. Then we had the scheduling kick in, everything. So it took about 4 days. So the entire thing is like 4 days. I want to write an article on this, or maybe even just give it to you in some plain text. And this is how you do it. This is what we do. These were the challenges. I want to show you, go through the challenges as well in the post, and then share it to you. So maybe the time when you look at it, maybe in case I've already completed the project, and if I've probably shared the link, you would probably see the list of Medium articles, or maybe what the articles or whatever the links available in the description. Okay, so just check it out in case you're looking at this in a very in a couple of weeks or a couple of weeks. Yeah. So we already have 10,700. Fan is kicking. Just 74 more. And of course, this is a 4 billion parameter embedding model. You have 8. You also have 0.6 billion versions of it as well. So if you want to do it locally, and if you have a very small business, you can go with 0.6. This is I've deployed this in Q8, I think. So no, sorry, Concept 4 version. That's also 4 GB. So takes about 5 GB, I think. Yeah, 5.10 GB of VRAM. Not VRAM, RAM. In my case, RAM. VRAM. Okay, just 24 more. Okay, I think this is the last batch. And 4 more. So 18,400 acronyms totally processed. Not acronyms, domain DTs. Done. Cool. That's it. Okay, we have 18,336. Okay, I think it's fast. No, wait, we can see the pharma search. Okay, did you test this thoroughly? Is everything working? And also, I wanted to know what is the, for example, for each for each for each for each term, I would like to pull the top three, or k equals to three, or something like that. And then, yeah, that's what I wanted to. I'm not sure how much you called in your test, but I think for each term we should pull in like at least three. And then, yeah, and we wanna fire off depending on the search term, depending on the key terms we get, but we want to process each term parallelly. No, no, wait. So how long does it take for each query to come out? Let's say we're taking the top three, or do you want to take the top 10 and see whether it's matching in any of the 10 variables? Actually, wait. But wait, a quick question. But would it match the other way around? So I think we need to do both. Yeah, Yuki, I can see a development plan. Are you using BMAD method for Taskmaster? What the hell? I don't even know what BMAD method and Taskmaster is in the first place. Um, yeah, to be honest, I have no clue about BMAD method. No, nothing. I see development plan. I mean, it's just a text. Development plan is just a text. Um, this is actually a quite old development plan, probably like 2 weeks old. We changed a lot of things in between in this vector databases. Well, I guess no, vector databases stick to this is still the same. Embeddings is still the same. Injection pipeline changed a lot, and we changed a lot in deploying. We changed a lot in the infra, mainly on the infra for processing 10,000 documents. Um, yeah. Apart from the search pipeline, it's just same. Yeah, I didn't use any tools, just Claude, just brainstorming. It's just complete brainstorming and just have like phased approach of building. And yeah, man. Feel free. Okay, and I like your post on Reddit. Yeah, thanks, man. Thank you so much. Yeah, I'll probably post something about this maybe on Reddit or Medium, whatever. Yeah, I plan to post it somewhere later. So yeah, hopefully, yeah. I'll clean everything up. I'll clean all this. That's the repo for Taskmaster. Bro, I don't understand anything. What do you mean? Dude, are you promoting your shit? Taskmaster, a task management system for AI-driven development designed to work seamlessly with any AI chat. You idiot. I'm pretty sure you're the guy who built this out and tried to promote this. But either way, I'm gonna check this out. Taskmaster AI. Better try next time. It has 25.6 stars on GitHub. Oh shit, oh, it's in GitHub? Oh, then, okay, it's an open source thing then. A task management system for... No, I don't use any of this stuff. I just manage my own tasks. I don't complicate things at all. I only, work on, just you can work on complex things. You don't need to complicate simple things. There's like a high level plan I use. And then, for example, this is one development plan that I have. I have, like split it out. I want to solve formula. I want to solve table extraction. I want to solve document processing. I want to do descriptions. I want to do for embedding pipelines. I want to do for re-rank. I want to do for this. I want to do for that. And all of those bunch of stuff, very simple, add it on. And then I will have separate files for each of them and then note all of them, whatever the main decision place I took. Maybe, for example, let's say I'm working on the agent, what was the, rationale behind building this agent? What Claude chats did I have? What what stuff did I try, what didn't work out, what did work out, and all of those stuff. And I used to dump it on a text and then sort of yeah, that's what I do. Just dump it on text and start just building, and then Cloud reference it because it has a lot. It Cloud will usually auto compact this, and most of the memory or the decision points or notes, everything is lost. But in this way, because I maintain like a proper phased approach file, I never lose it. So yes, it's quite simple. I'll check out Taskmaster in GitHub. Is it Claude Taskmaster? But anyway, yeah, I didn't, yeah, I don't use any other extra, context tools or whatever you may say. Um, yeah, I use Cloud Code. That's it. Simple Cloud Code, man. It's more than enough. And of course, you just have to, have more conversation, try to see what's happening in the background, sort of fix it. But this is like a huge project, to be honest. This might take like easily 3 months, 4 months with a team of five. Yeah, with Cloud Code, I'm able to usually, with this, I'm able to complete this in 2 weeks only because, I had a lot of issues in the middle in the infra side, but we were able to get that sorted out. And if I were to quickly show you, I'll quickly show you the because I think you guys, I guess about 5 people are watching. Maybe I can show it to get a sense of what we're doing. All good. Just when I saw the development plan, I thought it was one of his tools. No, man. No, no, no. I don't use anything. I'm gonna quickly show you. Uh, just a minute. I'll just bring this up. I'm gonna quickly show you this. You can see over here, and yeah, this is what we are dealing with. You can see the number of documents we are working with: 10,414, completed 1,700, and you can see there's 17 documents are currently being processed right now. Oh damn, then I think we actually have a concurrency rate of 8, like 8 documents being processed concurrently. And let me expand this. Now I think we're averaging about 104 pages a minute with failures and all. We have about 7.8 failures. This is like corrupted PDFs and etc. And yeah, we're running this for about 16 hours right now, and it's running on an H100. Yeah, we're not even 20% there, so I assume they'll actually take some time, probably like probably a couple of days, 3-4 days, and and but it's stable, everything is stable. I have watchdog set up, and you have no clue the things go wrong here. I have watchdog set up for everything. If one item instance go down, the model will the pipeline will automatically transfer the request to another server, and the other one using watchdog would actually load in the in less than 3 seconds. The docking server loaded on the GPU and etc. I'm going to show you the GPU. Yeah, maybe you get a chance to see NVIDIA SB. Actually watch. So yeah, if anyone like I'm sure a lot of people know how to build like like agents and all of this stuff, but solving infra is like a big headache. And how do you solve it with very limited amount of compute? I've only got one H100. And yeah, you can see all the models as are running. All of them are dockling models, and one of them is an embedding model, and then this one is a 7 billion parameter version. 7 billion parameter version only takes about a little 9 GB or something like that, but then all of the others 50 GB is actually for batching. This could actually process 256 in one forward pass. So I think there's a couple 8 workers running, and then everything is queued and all of them. Yeah, feel free to check out the last videos if you're quite interested in this stuff, because yeah, when you can solve document, you can solve so we solved like 3 main complex parts, at least 2 main complex part. One is document processing. How do you solve with using open source models? How do you do layout detection for formulas, tables, for diagrams and all of them, and embed them? Second thing, how do you do it at scale and embed them? So that's the second like point. We've solved both of them. The third challenging part is going to be building the agent that can actually work for 10,000 docs. That's the hard part there. So hopefully we'll figure it out. Follow me over on Twitter or wherever. I don't usually post on Twitter. I want to. Yeah, I leave any info that I have, and of course I'll put it on Reddit sometime when I have time. And yeah, we'll continue this. So again, we're working on domain terminologies here. We have about 18,000 domain terminologies. This is from NASA's Thesaurus API, not API actually. You can just download the entire SKOS, which is just a file filled with all the domain terminologies, with all the matching synonyms and etc., acronyms and etc. So yeah, that's what we're working on. I'm just trying to make it the semantic search fails very much for like 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 keywords like LOX, CBC and etc. Semantic search usually fails for that. For that, you only need to do a lot of like keyword matching. So I'm gonna have like a hybrid approach, I think, to do keyword matching and also semantic search. So a very hybrid approach. So I'm gonna do two. It exists, but something else is scoring higher. Let me see what's beating it here. What I want to do is use a re-ranker here. I don't know, but I don't want to waste I don't want to waste GBs of whatever. I don't want to use a lot of stuff. So cool. So you have liquid hair, liquid nitrogen, liquid hydrogen. The synonym suffix is hurting the match. Adding a synonym changes the embeddings and makes it less similar to plain query. Fix embedding prefill. Don't include synonyms in embedding text. Multiple embeddings per concept. One for yeah, then I need to reprocess this. Don't include synonym. I think even if we go with option 1, I'm not sure how accurate will be. It would be, I think we might find some success if we were to do hybrid where we do exact and plus semantic. So we probably have best of two both worlds. What are your thoughts? And I also had one more question. What if it was the other way around? For example, what if user searches for LOX, do we find? Now it's not about always the acronyms as well. The documents might just mention liquid oxygen without LOX. So the agent need to search both LOX and liquid. So it's like a handy operation. Like both have to work together. Yeah, matches pre-label also works. Matches. This fails in semantic search. If you do liquid oxygen matches pre-label also works. Find seduction. Trust failures. No match. No match. MMH matches. First, exact substring match and retrieval. Then semantic search for remaining slots. Consider duplicate. This solves both direction. Yes, let's go with this. Let's see how it goes. The goal is to give in acronyms just as a support and not confuse the model. So that's what we want to do. Like we don't want to confuse the model. Like it's easy to confuse the model. Like you can easily you can just dump in so many acronyms and the model will have no clue. The agent, it has to be very, that there shouldn't be any noise. And we got the LOX in 247 milliseconds. That's good. there shouldn't be any noise, and we also need to make it quite clean as well, because thing is like this, you'd actually have you'd actually have 4 or 5 queries in a single question. So that's what I'm saying, less noise, but somehow we need to find that sweet spot. Hybrid results, excellent. The hybrid is working. Looking at LOX now finds liquid hydrogen with synonyms. By now, model, yeah, good. Now finds model with synonyms. Score 9 point. Liquid hydrogen. Just a few more results. Good. So we're doing hybrid search here. In memory index for fast text search on auto labels. Okay. Yeah, 2 seconds. It's too much. Wait, wait. I think this seems to be a wrong. This seems to be quite wrong, because we don't want any. We literally don't want any. What can I say? We don't wanna. No, like adding S to turbo pumps. Wait, I don't understand. What are you trying to do? That's the reason we have semantic search, right? Search. Will re-ingest basically for label only. because we can't tell the users to search for turbo pump or turbo pumps. Like that's the reason why we literally have semantic search. Anyway, this will take a bit of time, but yeah, that's it. We'll remove all labels. Then I'm not sure how the other ones gets processed. Look. Wait, curious to know what's the difference with this approach? Because let's say if the user were to search LOX, would we find a good match? And also if the user were to search for liquid oxygen, would we still find LOX? Like, you understand what we're trying to solve, so don't overcomplicate this. Just let me know would this approach solve all of them? Because the thing is, you have this synonyms text inside the embeddings, right? So that might, I think that might mess with, I literally think that will mess with the semantic search. Not a lot, slightly, because the thing is, you're searching for keyword, not the entire query. We're not putting the entire query. So that's what I'm thinking. This is where you would do keyword search and like basic fuzzy matching and etc. Yeah, on embed text. Cool. What I'll do. All right, let's actually process this in a different collection. So we have the old one and also the new one. If we need it, we can switch back easily. Wait, then you have to update the code to store it in V2, right? No, it's fine. Just update the code for now. And I will actually run this. Okay. Do you want to run 300? How many embeddings are you running in a single batch? I have, I think from the last time I had about 4 GB of RAM left. We could have still done more. So I wanted to know. And with all, of course, you can still do another 8. It'll be a little bit slower, but because of the swap, but you can still run 8. Let's see. Currently, batch size is 500, which 4 GB RAM. You can easily do 2000. Oh shit, no. No, we'll keep it at 500. Run it. The fan should kick in. It'll take about 10 to 15 minutes. I'll take a little bit of time. I'll just be back in a few minutes. Yeah, I guess same speed. Even though we do 5, there's only limited, right? Yeah, we'll finish in another 10 minutes. Okay. Okay, then. Now we have only odd labels, and where is embed text? Yeah, this is the only embed text. If we find this, we'll of course send all of this as context. I'm not sure if we'll see an improvement. We'll see. I think we're indexing it. Let's see. V2 resolves. Yeah. Our problem cases to resolve now. The hybrid circuit P-level only everything is working correctly. Yeah, and also I want to look at like um, uh, just give me an understanding of how many chunks are you sending for the model for each key term, and how long does it how yeah give me an example of that, and also give me from a past test how much time does it take for hit to retrieval, because I'm just trying to understand the time it takes. If it's in milliseconds, if it's even second, it's okay. And still, even if it's 2 seconds, I don't think I'll work on like speeding up it now because I have to go out. Let's see. Yeah, 0.828 seconds. Fast, very fast. Yeah, it's literally like you can't sense something is happening in the middle. From a start to agent, 0.1 milliseconds to hash lookup, 75 to 135 milliseconds. This is not even a second, it's 130 milliseconds. Bottleneck embedding operation, Olama, that's still fast. And total per term, 100, yeah, less than, yeah, 130 milliseconds, very fast to me. LOX, so found 3 matches, skipped semantically, turbo pump 106 milliseconds, no text match, no full semantic search, embedding the bottleneck for multi-term specification, 5 terms sequentially 500, and parallel embedding is the limit, it's fine. Want to implement parallel processing now, I'll use thread pool worker to run lookups concurrently, look them in. Yeah, this is fine. So yeah, I think we're in good spot. I'm gonna end the live stream right now. Oh no, maybe actually we'll work on this, implement parallel processing, and I think this is going to be simple code, so I'll leave it at auto edits on, and yeah, I should make the general parallel processing and should give me yeah, so basically for each term, when a query comes in, a term could, we could have 3 to 4 terms, and then we'll dissect each term depending. This also comes from the model will decide what, that is the thing, no? Yeah, the model needs to, there's, yeah, there's a bit of time for that. The model, we'll use a very small model then for that, like a quick model. We'll try with HiQ for now, but later we'll just use a very small model that could actually predict, not predict, just give us an, just an array of text essentially. Sequential 412, 5x improvement, not 1.8x improvement, sorry. Yeah, basically you're reducing 50% the speed, yeah, increasing it by 50% speed. Cool. Parallel search results, 1.5x speed up. For 8 terms, we still are processing 8 terms in 181 milliseconds. 1.4x faster. Speed up is 1.4 consistently. Orama serialized embedding request internally, blah blah blah. Doesn't matter. And right now we can do hybrid search, acronym search, symbol retrieval, parallel multiple expansion, in-memory text, and also the collection is over here. Ready for engine integration. Yeah, I mean, we can integrate to the agent now, or we can wait a bit and integrate it. But overall, I think this was a productive session. It's only around 3 hours. We were able to accomplish a lot. Only because we solved all of those headaches in the past few streams. This is very straightforward, text embedding search. You just have to get the agent part right. Quite very straightforward stuff here. Still, anyway, if there's any questions, let me know. What I want to do is that I want to quickly run. Okay, I want you to, create a document and include all the information, the test results and etc. in a document, and also any needed information about this integration. So let's say we come back to another day and look at this, and we should be able to grab any decision making points or whatever, the test results or whatever. Keep it concise and keep it strong. Create a new MD file, name it, call it whatever you want. Okay, so in case I just want to document all of this, so we know the rationale behind why we made this search, why we made the hybrid search, and etc. So maybe let's say we look at this in a few weeks time, we'll know decisions and etc. regarding this specific feature. And there's also a very small feature. You don't necessarily need something like this. I'm just adding. So I'm just adding it. So just trying to follow the same development. What do you call it? Developments, not standard, but development tone and style, or the process, or whatever you want to call it. Okay, just a minute, guys. Sanjay? ஓ நான் பார்க்குறேன் ஓ இருக்குதா நான் பார்க்குறேன் நான் எடுத்து உள்ளே வச்சுடுறேன் போகிறதுக்கு முதல்ல This looks fine to me. Anyway, just a sample dump of text. Cool, we'll save it. Good. So terminologies, we have all of this working. What else? We'll actually integrate to the agent. Yeah, we now the thing is like this. This just can't be integration to the agent, of course, because um, I would think it's better if the model can call, get domain terminologies or something like that only when it needs to, because not always, like say you wanna, if the user were to, search something, whatever, you wouldn't always need to, you wouldn't always need to perform any domain terminology searches for that, right? Only when the model needs to search stuff or understand certain things, it can, perform it as a tool call, opposed to all questions. If all questions, we don't need to, send in the domain terminal. We don't want to send, you don't want to do this embedding sort of matching for every text. Doesn't make sense. We leave it to the model. So I'd be like, actually, before this, I want you to understand the entire system prompt and also look into a few simulations that we have already um, run through, because I want you to understand the series of this agent and how, how generalized and smart this agent flow and everything is, because it works entirely with the tools, and it also works, the system prompt is also very much in a way that it spikes up domain intuition. So I don't want this particular whatever to, sort of make some noise in that. It's quite simple, but I don't want it to. I also want to add this as a, what do you call, add this as an, what can I say, add this as an a search tool. I want not a search tool, but then a tool where before it performs searches, it can actually retrieve domain acronyms or whatever, and it can actually, use that tool, get access to this, and then it could perform the search. So this is actually in a very influences a very natural way for the agent to, for lookup stuff needed, because in the future it might need some clarification on some things, and it could, look up the domain terminology tool for that as well. So it has to go hand in hand with the entire flow. So I want you to first of all check everything, understand it, and then come back to me with a plan on how you're gonna do it. And it's fairly simple, guys, but I don't want it to, have a lot of noise. So yeah, because I don't want the model to, quickly hallucinate or just make up some information, and because this tool is different, the system prompt is different. I just want it to be in a flow. So for that, this agent has to, like the Claude code has to like get a good feel of understanding about what we're trying to do, like the entire flow, and then it needs to write it. Now conversation will compact, and again I'll tell it to encourage it to search it. Or also, I will always encourage you to use it when there is a search. But this is the tool. This is the tools. Yeah, we'll proceed. Bye, set terminology. The thing is, I want to add it as an injection, but yeah, the thing is like this. The agent might need to search many more information, and just basing the queries on just domain terminologies might not just work out. So better we have it as a tool so the agent can pull in, as it discovers more info, it needs to, check in more domain terminologies before it searches, then it can do it. If not, it'll probably be, injecting for depending on users question, injecting depending on search queries and etc., which is very inefficient. On domain terminology, I don't know if I'll keep this. I don't know, but let's see. Either ways, I think I have to head out. I'll come back and continue on this after this, but I think we should be in good spot after this in terms of searches and in terms of a little bit of bump in like the understanding part of it. So let's see. Anyway, I'll test it once I'm back. I have to head out. Thank you so much for watching the stream. We'll probably have the part 2 version. Talk soon. Bye.